So we're back within our workflow, and the UMAP has completed. And so now what we'll do is continue on with our Wishbone analysis. And so to get started, what we'll do is make a child task and choose Wishbone. Now, the first step in a Wishbone analysis is to run diffusion maps. And what diffusion maps is an algorithm that is a dimensionality reduction method that serves to pull out the major structure and trends within the data, projecting that information into a smaller subset of columns or dimensions of our existing data. And it serves not only to do that, but to denoise the data and improve Wishbone performance. This implementation of diffusion maps was provided along with the Wishbone code repository, which is why it appears as an option here. To get started, what we'll do is choose our file, and then we'll choose all of the markers here, but not the UMAP ones that we have from the previous task. And then we'll pretty much leave the settings default for now, except we will drop the number of result columns, just because I already know that they're unnecessary. And with that, we'll just give it a run. So we're back in our workflow again, and our diffusion maps run has finished. But in order to make it more clear that this was diffusion maps, because the Wishbone task itself has these sub-processes that you can run in it, we'll actually rename this just to tell ourselves that this was the diffusion maps run and not a Wishbone run. From here, we can take a quick look and just acknowledge that diffusion maps is a normal dimension reduction algorithm. So for example, we can bring up a plot and choose the diffusion map components, of which there's a fairly large number of them. And this isn't really the type of dimension reduction that you would use for most practical data analysis purposes, but we can see that there are in fact data, and they've been projected into these components. And we can look at multiple of these dimensions if we want. So for example, we could change to 3 and 4 and see that there's different information encoded in them. One thing we can also do that is pointed out by the authors of Wishbone is you can use a pre-existing dimension reduction, such as we have with our UMAP, and it's possible to color the diffusion components on this. And so they point out that this is an interesting way to kind of make sure that your diffusion components make sense in terms of your data. It's sort of like double checking them. So if we permute here just by the first 4, we can go ahead and see that the areas of our map are correlated with different parts of the diffusion components.